And we're going to look at how to do box plots, and we'll hit histograms again on the calculator as well as our 5-number summary. So if we're looking at our Chicago Cubs salary, what we did the other day, we have our mean and all this stuff. Again, if we want to see how we can do that, stat edit to put in our list, and we did it in millions so that we didn't have to deal with all the zeros. Then we hit stat and then calc, one variable statistics, and then we put the name of our list. So second stat, and we do I have it as list 2. So we have our mean x bar, our standard deviation S sub x 6.01. We have our minimum, Q1, median, Q3, and maximum. These are our 5-number summaries, or this is our 5-number summary. If we want our variance, we take our standard deviation and square it, so you have to do that separately. If you want the IQR, it's Q3 minus Q1, so 8 minus 0.5115, and we have all those different things. If we're looking at it at the Inspire, we put it as a list and spreadsheet. Then, again, to move from page to page, you can hit Control and then arrow. So if we get to a regular page, hit Menu, Statistics, Stat Calculations, and one variable statistics. And I labeled it Cubs. And we have all the same stuff. So that's how we can find our statistics. Now, first of all, let's make a histogram of this data. Again, just a review of what we have already done. If we have our list in there, second y equals, give us a stat plot. Make sure it's on. And then we can choose this one, hit enter. Make sure the list is right. X list is L2, which is where my Cubs data is. And we hit graph. And I have my distribution. We hit trace. We can see what they are. If these are by weird numbers, hit your window and your X scale becomes how wide our classes are. So I can do it as 5 as well. And then 0.5 is what they start at. So maybe I want to do 0 instead. So 0. Now if I graph it, I hit trace, minimum 0 to 5, and they go up by 5s. So that's how we can change this. Some of the numbers were a little bit nasty. On the Inspire, Control I to put in data and statistics. Click to add variable, and we'll do Cubs. There's our dot plot. See all the very similar data here. Under Menu, Plot Type, and Histogram. Now those classes aren't very good, so we'll change it to, there are too many rectangles there, that's why we're going to change it. So plot properties, histogram properties, and bin settings. Bin is our classes. So width, we'll do 5, and yeah, we'll start from 0 again. Oh, notice we can't see the top of it. So you hit Menu and you go to Window, do Zoom Data, and then it'll be a little bit nicer. Again, scroll over, you can see what they start and stop at, how many pieces of data are in there. So that's how we can get our histogram. Remember, we need a label on both axes and scaled. And we just label the lower class limits of the beginning, so 0, 5, 10, 15, 20, 25, and we need a title. We decided to do 5 because we took our range, divided by 5. I wanted 5 classes, and we got about 5. We'll round it up to a nice whole number. All right, we're looking at box plots. We are dealing with our 5-number summary. Our minimum, Q1, median, Q3, and our maximum. So each of those numbers split up our data into quarters, hence quartiles. So if we look, and this is kind of tough because these two numbers are very similar, but between minimum and Q1, it's 25%. Between Q1 and the maximum, well, that's 3/4, so it's 75%. Between 2.5 and 25, that's, well, 2/4, so 50%. Same for 5, 1, 1, 5, and 8, that's 2/4. So we're just adding up quarters here. Again, it's kind of tough to tell because we have a lot of 500,000s. All right, so what we're going to be able to find out now are outliers and a box plot. So let's look at a box plot first. A box plot is just our 5-number summary graph. It's here is Q1, and happens to be our minimum both there because they're close. Then our median, Q3, and our maximum. And we'll talk about what this is in a second. So again, we want to make box plots on our calculators. Control, actually, we don't have to do that one. If we're on the histogram, go to menu, plot type, and just change it to box plot. And there we go. And you can kind of scroll over it. Q1, median, Q3, maximum, kind of point chilling out here. It doesn't tell us our minimum because they're too close again, but we have our box plot. If we're using the 84, let's see, there we go. We second stat plot, and then we just choose the box plots instead of the histogram. Now there's two of them. The first one shows us any outliers. The second one is just a box plot without calculating any outliers. So if we do this one and then graph it, there's our box plot. Same thing. Again, scale is not great, so we could change that. Again, this is what it goes by. However, it's probably nicer that we can do this one, and then it's the same as the Inspire, and we have this outlier. So, if we hit trace, we can see our 5-number summary as well. So that's how we make our box plots. If we're talking about how to find outliers, outliers are extreme values that are too far away from the rest of the data. They're outside our fences or our boundaries. Our upper fence is Q3 plus 1.5 times our IQR. And the lower fence, I should say lower, is Q1 minus 1.5 times IQR. So really, we're trying to see that they're too far away from Q1 and Q3. And 1.5 times the IQR is kind of our rule of thumb. So our upper fence, Q3, which is our 8, plus 1.5 times our IQR, which is Q3 minus Q1, we get 19.23275. Notice 25 is bigger than that, which is why 25 is an outlier. So John Lester is an outlier. Our lower fence, it's Q1 minus 1.5 times our IQR. We get a negative number. Obviously, there's no values that are less than the negative 10. So a lot of times we don't have any lower outliers. But as we saw on the box plots, they show us our outliers. Last thing, we look at the different shapes, symmetric, skewed right, skewed left. You can see what the box plots look like. Our box plot is very symmetric for a symmetrical or normal distribution. Skewed right, we kind of have this longer tail here. And skewed left, we have the longer tail on the left, which makes sense. Now we're trying to figure out what kind of center and spread we talk about. If it's symmetrical, we use the mean for the measure of center because it's right in the middle and that's what we want. And the measure of spread is standard deviation. If you have skewed left or skewed right, especially extremely skewed, we use the median because it's a better measure, and IQR. So we have those options. Again, remember it's part of our SOX when we're talking about a distribution.